Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P2626, indicates an open malfunction in the air-fuel ratio, AF sensor circuit, specifically sensor 1, which is critical for evaluating the air-fuel mixture in the engine. The AF sensor assists the powertrain control module, PCM, in adjusting fuel delivery for optimal combustion and emissions control. Located in the exhaust stream, this sensor works by generating a voltage signal that the PCM interprets to determine how rich or lean the air-fuel mixture is. A malfunction could lead to reduced engine performance, increased emissions, and potentially long-term engine damage. The PCM detects whether the calculated parallel resistance exceeds a specified limit, prompting it to store the DTC code. Addressing this error involves assessing various components, including the AF sensor, the corresponding circuit, and the PCM itself. The air-fuel ratio, A/F sensor, commonly known as sensor 1, plays a critical role in ensuring the engine runs efficiently. It measures the level of oxygen in the exhaust and sends a signal to the PCM, allowing it to adjust the fuel mixture accordingly. This sensor is situated in the exhaust system, typically before the catalytic converter and the primary exhaust gas treatment systems. The PCM, which stands for Powertrain Control Module, uses the information from the A-fuel ratio sensor to make real-time adjustments, maintaining an ideal air-fuel ratio for combustion. When the sensor circuit is open or has high resistance, the PCM can no longer receive the proper signals, triggering the DTC P2626. The comprehensive inspection of components involved in this circuit is essential to rectify the malfunction and restore vehicle performance. When diagnosing DTC P2626, several possible causes should be considered. A primary suspect is a faulty AF sensor, sensor 1, which may not be operating within specifications and can cause erroneous readings. Next, open circuit connections, including frayed wires or disconnected plugs, can interrupt the signal flow between the sensor and the PCM, leading to the stored DTC. Lastly, a malfunctioning powertrain control module, PCM, can also result in this code if it fails to interpret or act upon the signals from the AF sensor. Each potential cause must be examined thoroughly to properly identify the root of the issue, ensuring effective repairs. The symptoms associated with DTC P2626 can adversely impact vehicle operation. Poor engine performance is often the most noticeable issue, characterized by rough idling or hesitation during acceleration. Increased fuel consumption may also occur due to improper air-fuel mixture adjustments by the PCM, resulting in a less efficient burning of fuel. Furthermore, drivers may notice a warning or check engine light activating on the dashboard, emphasizing the need for attention to the vehicle's performance. If left unaddressed, these symptoms can lead to more severe engine issues, as the PCM struggles to achieve the optimal emissions and efficiency. Monitoring these signs is critical for timely maintenance. The first step in troubleshooting DTC P2626 involves starting the engine and holding the speed at 3,000 RPM without load until the radiator fan engages. This step is crucial for simulating operational conditions where the A-factor F sensor is expected to function optimally. Holding the engine at this speed allows the PCM to assess the sensor's readings in a controlled manner, providing clearer insights into whether the A-factor F sensor circuit is indeed functioning correctly. If the PCM detects any irregularities during this test, it will log the corresponding data, which will help further identify potential issues that may lead to this DTC. The second troubleshooting step requires inspection of the external circuit related to the AF sensor. This includes performing an open wire inspection for both the LAFCA and LAFCP signals. To complete this process, technicians should examine the female terminals of both the AF sensor and PCM connectors to ensure proper connectivity. Further scrutiny of the wire harness is essential, as any break or disconnection can lead to the open circuit that triggered DTC P2626. It's important to check for signs of wear, corrosion, or damage that might interrupt the electrical signals. If abnormalities are detected, addressing these issues is crucial before proceeding with inspecting the sensor itself. In this step, technicians will disconnect the AF sensor, sensor 1, and utilize a known good component for comparison. Substituting the faulty sensor with a functional one allows for testing whether the original sensor was the source of the issue. The objective is to reproduce the failure state. If symptoms persist even after the replacement, it indicates the problem lies elsewhere, possibly with the PCM or the circuit connections. However, if replacing the sensor resolves the issue and clears the DTC, it confirms that the original AF sensor was faulty. This method offers a practical approach to diagnosing the issue by ruling out possible culprits systematically. The final troubleshooting step involves PCM inspection if previous tests have indicated normal conditions for the circuit and AF sensor. To assess the PCM, technicians must check it for any faults or irregular performance that might contribute to the DTC. The PCM is responsible for processing signals from various engine components, and a malfunction here can lead to misinterpretation of sensor data. If after isolating other components, the PCM is the only entity that shows irregularities, it is likely faulty. This assessment is vital, as replacing a PCM can be complex and often necessitates programming, making it essential to confirm its integrity. After all necessary repairs have been made in response to DTC P2626, it is crucial to verify that the vehicle operates correctly. This involves clearing the DTC from the PCM using diagnostic tools, followed by a test drive to assess the vehicle's performance under real-world conditions. Monitoring the vehicle during the test drive helps ensure that the engine runs smoothly without triggers of the DTC again. If the symptoms reappear or the DTC is stored again after the repair, further investigation may be necessary to ensure proper function of all related components, such as the AF sensor or wiring. Successful completion of this step confirms that the necessary repairs were effective. Preventive maintenance is essential for avoiding issues such as DTC P2626 in the future. Regular inspections of the AF sensors and their associated wiring connections help catch potential issues before they escalate into major faults. Keeping the wiring and connectors clean, secure, and free of corrosion can greatly improve the reliability of the system. Additionally, staying updated with any software updates or recalls for the PCM can enhance its performance and maintain compatibility with vehicle sensors. Implementing routine checkups in your vehicle maintenance schedule can save time and money, ensuring longevity and reliability in your Honda Civic. In summary, DTC P2626 signifies an open circuit malfunction in the A-factor air sensor circuit for Honda Civic models 2022 and beyond. Diagnostic troubleshooting includes a structured approach, starting from engine tests to in-depth component inspections, ensuring no stone is left unturned. Inspecting each potential cause, including the A-factor sensor, circuit connections, and PCM, provides a systematic way to identify and rectify the issue. Once repairs are made, validation through test drives confirms operational integrity. To further circumvent such DTCs, preventive maintenance is a key strategy that involves regular checks and system updates. Familiarity with DTC codes aids in prompt recognition and resolution of issues, thus maintaining optimal vehicle performance. Please like and subscribe to the channel. See you next time.